Good afternoon, everyone. Welcome to another webinar at Scifest Africa. My name is Mponyana Mbikanye, and I will be your host for today's session. To give a background on our speakers for today, these are high school learners who were awarded by Scifest Africa at the Eskom Expo for Young Scientist ISF 2021 for the Best Communicator Award. I would like to say welcome, and if you have any questions, you can drop them on the Q&A and also on the chat box, and also you can raise a hand and you ask a question. Our first speaker for today is Kutlwano Tshatiwa. Kutlwano Tshatiwa is a 16-year-old doing grade 12 at Gabonewe High School in Madikwe. He is passionate about solving problems using artificial intelligence. Some of his achievements include winning first place gold medal at the Puka IMSEF 2021 in Turkey whilst representing his country, as well as Eskom Expo for Young Scientists. He was also named the overall winner in the category of Computer Science and Software Development at Eskom Expo for Young Scientists 2021. He also won the MTN TED Hack Rising Star Award in 2022. Over to you, Kutlwano, and all the best on your presentation, sorry.
Thank you very much. Let me quickly share my screen. Please let me know if you can see it. Please confirm if you can see my screen. Okay, thank you. So my name is Kutlwano Tshatiwa, as it has been said, and I'm working on a project called DoctorNet, and then there is a prototype. So the purpose of this project, or the purpose of this project is that I want to assist medical doctors in like addressing this problem of like people being misdiagnosed or rather being late diagnosed. Like for instance, you imagine someone being diagnosed at a later stage of their condition. It obviously means they will die. Or imagine if they are diagnosed, then imagine that they are said not to be sick, whereas they are, it means they will be sick. They will die because they will not be receiving proper medication. And then so in order to solve this, I developed a machine learning algorithm, and then just for now, I'm using pneumonia and skin cancer as a proof of concept. But obviously, other radiographic diagnoses will be applicable. So obviously, like I said, the aim is very, very simple, which is to help reduce the number of those people dying, be it with misdiagnosis or late diagnosis. And I'm obviously solving this using machine learning, like I've mentioned, since like rather than a doctor who looks at an X-ray image for maybe for too long and then to determine if someone is sick or not. The machine learning algorithm, what you just do is that you upload your picture, and then on the fly, it just tells you if you are sick or not, as well as the confidence that it has. And then obviously, my engineering goal was that the machine learning algorithm, I just wanted it to reach at least 70% accuracy, minimum. I just wanted it to reach 70% accuracy in diagnosing pneumonia, and skin cancer. And then in terms of the procedure that I used to develop this algorithm, what I did is that obviously, first of all, you gather the data. So the first step was that I had to gather the data set. I had to gather like images. For instance, I had to gather images for people who have skin cancer, like skin cancer on the like cancer on the skin. I had to have pictures for that, and obviously there had to be more than hundreds of them. So I had to have those for those that are positive and those that are negative, and then I as well had to have for those that have pneumonia as well as those that are negative. And then the second step was that I had to prepare the data. I had to make it machine learning ready, because you can't just take images and then just feed it to machine learning algorithms, because machine learning algorithms only can understand or read numeric representations. So obviously I had to convert those pictures into vectors and things like that. But obviously we have wrappers such as TensorFlow, which is a machine learning framework. So it helped a lot in terms of doing that. And then obviously after preparing the data, the next step was now to design the algorithm, to now start coding the algorithm. And then what I used is that for that I used TensorFlow again, because I mentioned like it's a machine learning wrapper or API, you can say. So it sort of handles all the mathematics for machine learning behind the scenes for you. So that's what I used. And then the type of machine learning architecture that I used is a CNN, which is commonly known as convolutional neural network. And then it's very widely used for image classification, image recognition, and things like that. You name them. And then what happens is that obviously I designed the algorithm. Now I use Python programming language because TensorFlow uses Python. So after developing the algorithm, now I had to train it. The next step was now training the algorithm. That's why by now I had to sort of, when I started training it, I obviously had to sort of implement few algorithms which are gonna improve the accuracy of the machine learning model. So my machine learning model all in one, like it consists of a CNN network, as I mentioned. And then in terms of the optimizer, like for instance, the algorithm to be able to correct itself while it's training, obviously uh, um, I used a categorical cross entropy for calculating the loss, literally like the mistakes that the algorithm made. And then I used Adam Optimizer as an optimizing algorithm for the loss to be minimized so that I reach the most minimum loss ever. And then obviously after training the algorithm, you can't just take it to people and say, I have an algorithm which can do 1, 2, 3. So I then had to evaluate it first. I had to test the algorithm first to see if it really does what I wanted it to do. And then in terms of evaluating the algorithm, I didn't just use accuracy alone. I used F1 score as well, which is like the average of precision and recall. And then just to make to take it to simple terms, precision and recall are something like out of all positive people who had pneumonia, how many people did the algorithm sort of get that correct? I hope I'm understandable. So yeah, that's the main algorithm which I used for testing the algorithm. And then obviously I tested it on test data. When I got my data, before preparing it, I first splitted it into train and test data so that I can be able to train it on the train data, obviously. And then after test it on the data that's assigned, on the images that it has never seen before, on the images that were not on the training data, because machine learning algorithms, AI, I mean, it's just like human beings. You cannot, for instance, you cannot go to class and teach someone mathematics examples and then as well test them on those very same mathematics examples. So you have to change so that you can see how the algorithm or the learner generalizes. And then the last step of the project was that after evaluating and then getting the results I needed, the next step was deploying to an Android device using TensorFlow Lite. So what actually happens there is that I took the machine learning model, obviously, because it was just a normal machine learning algorithm. But obviously, I needed to fit it inside an Android phone, an Android device, on an app, so that people can just diagnose X-rays with just like their phones, and it's offline. That's the magic of using TensorFlow Lite, is that it's offline, especially considering that we are in Africa, whereby internet is a huge problem. So with like taking that model in order for it to feed inside a mobile device, I had to quantize it first And what I mean by that is that I had to shrink it such that it can fit inside an edge device, like an Android device, your Raspberry Pi, and so on. So that was the last step. And then let me go back to when I was designing the algorithm. What actually goes on behind designing a CNN algorithm is that there is a convolution layer, which is like for extracting features from the image itself using obviously mathematical operations. But obviously I mentioned TensorFlow does the maths for you. So one of the common things for feature extraction in the convolution layer is that common wise multiplication is done there. And then after the layer that will normally follow is the mixed pooling layer, which sort of like takes the maximum features or something like that. So that's actually what's happening behind designing a CNN algorithm. And then here is my prototype snapshot, whereby since the last step of the project was deploying it to an Android device. Now, after I had deployed it to an Android device, I then here tested it out. As you can see, we've got on the first screenshot on our left. So what actually happens is that I was diagnosing an image I got from the internet, which was skin cancer positive, which is malignant. And then as you can see, the app with the machine learning algorithm behind the scenes was able to tell that this is skin cancer malignant. And then as well, it was able to tell that I am 99% sure of whatever it is that I'm saying. And then obviously on our right there, I was doing, I tested, this one is my hand. I just shot my hand and then I sort of diagnosed it. And then as you can see, it said I'm skin cancer benign. Benign meaning I am negative. And then you can see as well, it comes with very huge levels of confidence that, okay, this is 99% sure, which is very true because I don't have skin cancer. And then obviously, in terms of the results, my engineering goals were reached sufficiently as the machine learning model or algorithm can diagnose all diseases it was expected to be able to diagnose, and with a very good accuracy as well, and F1 score of more than 80%, which is like 10 more of what I had expected. Hence, I say my engineering goals were reached. And then obviously the machine learning model was saved in TensorFlow Lite, as I've mentioned, so that it can be used without internet connection, which is obviously a very big advantage for people in rural areas and things like that, people who actually do not have access to be it healthcare as well as internet access. So in terms of the discussion, the machine learning model obviously is developed, but obviously there are a lot of them out there. There are a lot of machine learning models out there for this very specific task that I'm doing. But one thing that I have found out during my research is that most machine learning algorithms for medical purposes only focus on one condition. For instance, there was a learner, I think in 2019, who did something similar. However, it was only for one condition, which was pneumonia. And in terms of my own algorithm, what I'm actually doing and working on is that I want it to be more general. I don't want it to just focus on one condition. Hence, for now, it can diagnose skin cancer, pneumonia, and obviously, I hope and still working on it so that it can generalize on many more other diseases. And then, in terms of the limitations that I've reached during the development of this machine learning algorithm is that on the first version of the algorithm, I had used TB images, tuberculosis. They were also used, so it was 3 conditions, which was pneumonia, TB, as well as skin cancer. But one thing I found out was that the algorithm was confused in terms of what's TB, and what's pneumonia. However, one thing that I found out while I was studying about TB and pneumonia is that the algorithm confusing things was not due to any correlations between TB and pneumonia, but rather it was due to a class imbalance problem in the data set, whereby there were more pictures of pneumonia, and obviously it was like over 1,000, and then there were less than 500 images of TB, which is very, it's not good. Class imbalance in machine learning is not good, because you teach the learner, you teach the machine learning algorithm to know the other class and not know the other class. For instance, you make it like biased. It knows pneumonia more than TB. So most of the time it sees an X-ray image, it just make a wild guess and say, this is pneumonia. Another thing is that, obviously, I said the algorithm should be able to generalize on not only one or two diseases, but too many of them. But rather, the limitation that I have is that in order to train these large machine learning algorithms, you need very powerful computing machines. I'm talking GPUs, powerful ones. I'm talking as well RAM, memory, and things like that. So it's very, very difficult to train on a laptop such as mine, which is like only 8 gigabytes of RAM. And then obviously there are cloud things such as Google Cloud, which you can actually use for training large networks, so that you train on the cloud and not on your local machine. However, problems and limitations with that is that you are only limited to few hours of doing a machine learning algorithm or whatever, and then you are limited to a very certain amount of RAM. So unless obviously you take the premium subscription. Thank you.
Thank you so much, Kutlwano. That was great. That was very brilliant. If any has the question, please put on, raise a hand, and then you can ask the question. And also you can also drop it on the Q&A box. There is one on the Q&A box. Let's see. Kolosa Makolo is asking Kutlwano, what inspired you to do this project?
I live in a rural place, or rather a township, very small. And what's actually happening is that obviously there are no, I don't even think there is one doctor at our local clinic. So it's very difficult to like go get diagnosed with, like if you suspect you have cancer, it's very difficult for you to go and get diagnosed, because we do not have at all doctors, or rather I should say doctors who specialize. For instance, we don't have radiographers and things like that. And again, it's very, in order to get diagnosed or whatever, you have to go to town, which is like more than 100 kilometers away. And then thirdly, because like, okay, this is for rural people. And thirdly, because a machine learning algorithm, in order for it to learn a specific task, like for this very certain specific task, I trained it for like an hour or but less than 2 hours. And then be it maybe we wanted to train radiographers for my rural area, it will be a problem in the sense that first of all, it will take time for them to get skilled. Secondly, it will, most of them, like they will go to school and then get skills on radiography, but not all of them would come here and work on the rurals. So yeah, I think I've answered the question.
Okay, there's another question, Kutlwano, from Miss Monica. Is saying that, thank you for the wonderful presentation. Has this project made you think about a career in science, medicine, or technology? Oh,
obviously it has. There is absolutely nothing that I want to do, be it it's not computer science, specifically specializing in this powerful technology, artificial intelligence.
Okay, great. Is there anyone who has the question? You can drop it on the Q&A box, or you can raise a hand and ask the question. I guess, thank you again, Kutlwano, for such an amazing project, and I hope we've learned a lot from this. Okay, going to another speaker. The second speakers for the day We have Emma and Katie Jamie. Emma and Katie Jamie are students at St. Prince's School in Cape Town. They are both passionate about the natural world and are looking forward to becoming involved in conservation work in the future. They are both also have love for literature and debating. Katie is extremely passionate about history and is the head of the Model United Nations and debating clubs at the school. She has her black belt in karate and also participates in the horse riding outside of school, whereas Emma is heavily involved with music both in and outside of school, enjoys dancing ballet, is the head of the school magazine and volunteers at the Two Ocean Aquariums. She's also the deputy girl at the school. There they are. Thank you. Over to you, girls.
Hello, we're Emma, Beth and Katja, and we're going to start our presentation now. Our project is entitled Daisies Down River. We are honoured to have been awarded a Top Communicator Award in the 2021 Eskom Expo for Young Scientists, and more so to have the privilege of presenting our project to you today. My name is Emma Beth Peters.
And my name is Katja Jamie.
And we are grade 12 learners at St. Cyprian's School in Cape Town. We are both fascinated by and care deeply for the natural world, and therefore created a science project that reflected the impact of human activity on the environment around our homes. We could not believe it when we won the Environmental Sciences category at the Eskom International Science Festival, but we're extremely grateful that our small message of human impact made a larger impact than we originally intended. Our project is entitled Daisies Down River, and investigated how varying degrees of human impact along the Liesbeek River, from minimal near the source to severe in the lower reaches, affected the plant growth in the surrounding area.
The aim of our investigation was to determine whether varying degrees of human impact along the Liesbeek River resulted in changes in the pH levels and number of contaminants in the water, and whether this subsequently influenced the growth of plant life along the river. We began with the hypothesis that different sections along the river experience varying degrees of human impact, ranging from minimal to severe, and therefore different degrees of water pollution. It was thought that the plants grown with the water nearest to the source, and therefore having suffered the least human impact, would grow the fastest and with better health than the plants watered with the water collected from the canalized sections, which had suffered more severe human impact. This hypothesis is founded on the fact that there's higher density residential housing around the lower reaches of the Liesbeek River, and therefore more pollution in these sections. Additionally, pollution is known to affect the contaminants in and pH of water, which in turn can negatively affect plant growth.
Our experiment involved growing plants using water collected from 4 different locations along the Liesbeek River. The water samples were tested for contaminants and pH, the expectation being that the water near the source would have a more neutral pH and less contaminants, and the water from the canalized sections of the river would have more contaminants and a less neutral pH due to increased human impact. Water sample 1 was collected in Stellenbosch Gardens nearest to the source of the river, and the numbering continued down the river, with sample 4 being collected furthest from the source at the endpoint. We then grew 2 sets of 5 African daisies, 1 for each water sample and 1 control, using the collected water, and observed their growth. Human impact on rivers is an enormous concern. The Liesbeek, in particular, is situated in 2 delicate bioregions, suffering from both physical and thermal pollution. Both of the Liesbeek's bioregions are nationally endangered and have conservation targets. The intention of our research was to allow a better understanding of how to conserve this beautiful river. Furthermore, the Liesbeek is a wetland ecosystem, and wetlands are the most threatened ecosystems in the world. Since we examined varying degrees of human impact along one river, it is possible to determine from our research which specific sites along the Liesbeek are in greatest need of concentrated conservation efforts.
We predicted that the pH of the water would become less neutral as it flowed further from the source and encountered more human impact. Although the first 3 water samples all had the same slightly acidic pH of 6.2, the water from sample 4 indeed had a higher alkaline pH. This increase in pH is likely due to stormwater runoff from gardens and homes that is prevalent in the lower, more polluted reaches of the river. We also found that the water furthest from the source contained lead, which is a highly toxic pollutant that enters the river through dumping or stormwater drainage. As predicted, the amount of nitrates increased along the length of the river, as their primary sources are fertilizer, manure, sewage discharge, and stormwater runoff. The amount of phosphates, on the other hand, decreased down the river, possibly due to the fact that the upper reaches of the river are more susceptible to organic enrichment than the lower reaches, with the more fertile soil in the upper reaches contaminating the water with phosphorus, which would then be diluted as the plants along the river take up the nutrients. The increased nitrates along the river suggest that the water furthest from the source, which flows through a high-density residential area, and the section of the river subjected to multiple stormwater drains, experience more human impact than the other water collection sites. Additionally, the water from collection site B was shown to be extremely similar to the water from collection site A in both the water and soil tests, which explains why the plants watered with these two water samples grew to similar heights and at similar rates. The only major difference between water samples A and B was the result for hardness, with water sample A having a hardness of 0 and water sample B from slightly further down the river having a hardness of 100, suggesting that hardness in water is detrimental to plant growth.
The plants watered with the water from collection site C reached the second lowest height of the 4 plants in experiment 1, ending up slightly shorter than plant B and slightly taller than plant D in the final measurement. Additionally, the plants watered with the water from collection site C grew the worst of all 4 plants in experiment 2. This is most likely due to the increase in pH along the length of the river, as a lower pH optimizes photosynthesis, allowing the plant to grow more efficiently, while a higher pH has been found to have a negative effect on plant growth. Additionally, the presence of the toxin lead in the water furthest from the source likely hampered plant growth, with the plants watered with water D growing 20% shorter than the plants watered with water A. These results show that human impacts indeed varies along the Liesbeek River, ranging from minimal near the source to severe in the lower regions, and moreover, that this has a pronounced effect on plant growth along the river.
This investigation opens up new and highly important avenues of research that can be done in order to further protect South Africa's incredibly precious waterways. We believe that additional research should be conducted to further investigate human impact on rivers and to better understand what type of conservation efforts should be concentrated along South Africa's most ecologically important rivers, as well as where exactly these efforts should be concentrated. Future researchers should focus on ways in which to rehabilitate water sources that are affected by human impact, possibly by removing heavy metals such as lead, which we found in the Liesbeek, and restoring the pH of the water to a more natural level. Engineering investigations should also be carried out to assess whether stormwater could be purified before flowing into water out of stormwater drains. Additionally, researchers should review whether the Rondebosch and Rosebank canals could be made of a different substrate or even redesigned completely, as it's evident that the cement that the canals are made of currently increases the water's pH slightly, which then affects the plants along the river.
Our investigation examined the effects of human impact on the Liesbeek River in order to allow a better understanding of how to conserve and protect the rivers that play such an important ecological role in South Africa. Moreover, as the effect of varying degrees of human impact along a single river was examined, it is possible to determine which specific sections of the Liesbeek are in greatest need of concentrated conservation efforts. Ultimately, this research was conducted to better understand and therefore better protect the Liesbeek River, which is an integral part of the wetland ecosystem in Cape Town.
Thank you so much for listening to our presentation.
We will now be open for questions.
Thank you, Emma and Katie. Thank you so much. That was an amazing presentation. I'd like to open for questions. Again, if you would like to raise a hand and ask them a question, you can do so. And also, if you want to write it on the Q&A box, you can also do it so quickly. Okay, there's a question on the Q&A. Ms. Monica again says, thank you for a very interesting presentation, Emma and Katie. Are you planning on any additional research in other sensitive areas?
Thank you for the question. We are not currently planning anything. We don't feel that we have the resources necessary at the moment. But hopefully when we enter university, we can start looking at that kind of thing because it really is of great interest to us.
Okay, there's another question that says, how does pH level affect the growth of plants?
So what we found during our research is that an increased pH has quite a substantial negative effect on plant growth. So it interferes with the plant's ability to photosynthesize, and then the plant can't kind of grow adequately and can't reach optimal height. So we actually found that with the plants that we grew, the ones grown with the water with the higher pH grew significantly shorter than the ones grown with the water with the lower pH, which was really interesting for us.
Okay, great. There's another question that says, from Annalisa, that says, what can people who live closer to the sources of this river do to keep their river clean?
This is a really nice question, thank you. And it's a very simple, nice answer because we can all contribute towards this. So it's things like not using harmful fertilizer in your gardens. These are full of nitrates and phosphates that are polluting the water and are detrimental to plant growth. It's also things like not dumping rubbish outside of the required areas. So please put your rubbish in a bin because this rubbish eventually gets washed down into rivers and acts as a pollutant. It's also things like not washing your clothes in rivers. So any soaps that you use, that's also going to have a massive effect on the pH and contaminants of the river.
And I think if you want to do something even more active, obviously getting involved in river cleanups or anything like that, we both live really, really close to the Liesberg. So you can sometimes go down, clean up, pick up a lot of the physical rubbish that you see. And I think that's really helpful to the river.
Okay. There's another question that says, what inspired you to do this research from Gabonewe?
I think to begin with, we're both really, really interested in conservation and how best to look after the planet in general, but we also live really near the Liesberg, so we see it every day, and we could see, well, I can see from where I live near the canals that it's quite badly polluted, and we were both interested to see what sort of effect that was having on our local kind of fauna and flora.
Yes, exactly. So we live on two opposite ends of the river. I live nearer to the source, where the river's beautiful and clean and flowing, and there's a lot of indigenous plant life. Whereas where Kacha lives, by the canalized sections, there's not as many plants growing along the river. And this was just something we noticed driving back and forth between each other's houses and just
immediately evident to see the difference between the two sections in the river. And it's an incredibly short river. You can walk the whole length, and I mean an hour or so. And where I live, there are almost no kind of indigenous plants. It's just weeds and rubbish. So
yeah, so it was so evident. We really wanted to see what exactly was going on in this river to make these marker changes.
Okay. Thank you so much, Emma and Katie. I hope we've all learned about how to conserve our rivers, as they actually play a vital role in our lives. The next speaker that we have is Ra'ees De Witt. Ra'ees De Witt is an expressive person who is curious about learning and consciously practicing shifting all forms of judgment to curiosity, opening himself to the vulnerabilities of being a student to others. He enjoys reading African American literature, classic feminist, as well as esoteric works. Between playing hockey and appreciating family time and making art, which is painting and drawing, he expands his path of both the destructive yet revitalizing elements of his reality to explore and express this human experience with total freedom. Welcome, Ra'ees, and over to you.
Thank you so much. Good afternoon, everybody. I would just also like to thank Scifest Africa for giving me this opportunity to present my work. My project title, I will be discussing my project right now. Just showing my screen. There we go. So my project looked at mitigating impaired drug absorption to shorten medical treatment as well as enable pharmaceutical product development by studying the drug paracetamol. So just to give a brief introduction, there's a concept in pharmacology called oral bioavailability. Oral bioavailability basically looks at what percentage of a orally administered drug actually takes effect at a therapeutic site after it's been ingested. Many drugs that I found from research have a heavy first pass effect, which means that a very minimal amount of that drug actually reaches systemic circulation and takes effect at a therapeutic site. To illustrate this, here are a few diagrams. So when you ingest a pill, it will reach its first site of action, the stomach. This is specifically what I chose to study during my project, and it will be absorbed and metabolized along the small intestine through the various microvilli walls. I will first be contextualizing the project to give a bit of background. So my problem statement was looking at the impairment of drug absorption and trying to find a way for efficient metabolism in high gastric fluid, because the stomach, as I had said, was the first site that a orally administered drug makes contact with. I wanted to identify optimum gastric pH, which ranges between 1 and 3.5. I wanted to offer practical implementation solutions and contribute to development of pharmaceutical products so that people have a more effective and successful response to when they administer drugs orally. My hypothesis was that the drug would have greatest presence and prevalence in its most acidic range of 1 over 30-minute treatment period. I chose to study the drug paracetamol because it is one of the most commonly orally administered drugs. I mean, when we look at a 2008 statistic from the US FDA, 24.6 billion tablets of paracetamol were sold. Looking at my methodology, I wanted to make a universal contribution. Then I designed 2 different test groups. A test A, looking at a chalk tablet format that is applicable to children between ages 6 and 12, and then post-pubescent or adults. And then a test sample B for pediatric syrup for minors between 3 months and 12 years. This allows for results to be seen across the range of all people that can administer paracetamol. Then I also had negative controls throughout the process for comparison and validity. My experimental design was comprised of 4 different steps. Basically, I first determined the pH range of the gastric fluid, ranging between 1 and 3.5. So I designed my test in such a way that each pH group would be tested at 0.5 intervals. So pH 1, 1.5, and so on until 3.5. Then I did my experiment at home using a microscope and various other apparatus, including hydrochloric acid and sodium hydroxide with a pH meter to manipulate the values. These images that you see alongside are all the pictures that I took through the microscope lens in order to do a mark recapture technique in test A. And then that green liquid that you see next to experiment conduction, that was for my test B group for the pediatric syrup. In test A, looking at the chalk tablets, I used mark recapture, as I said, basically looking at a 1 cubic centimeter concentrated area of drug, and then using a method of interpolation to estimate the total number of paracetamol molecules visible within the gastric range for a stomach, the average human stomach size. In my test B group for pediatric syrup, I used an anti-logarithmic equation in order to determine the pH changes due to the paracetamol being added into the gastric fluid. I am now going to walk you through my results and findings. As you can see on the left-hand side, this is the average prevalence of visible paracetamol across the human stomach for a post-pubescent person, so the adult group, test A. It has a positively correlated trend line showing that paracetamol, being an acidic drug, is best absorbed in an acidic environment. This proved my hypothesis that I had predicted. However, if you look at the pH of 1, it had the lowest, well, amongst the lowest presence and prevalence. This was because unionized drugs remain in the stomach due to the fact that it is an acidic region. Basically, when we look at the human body, unionized drug molecules pass through the GI tract, and then lipid-carrying proteins promote a longer half-life of the drug to avoid first-pass metabolism. That was one of the conclusions I made from the test A group. So that explains why the curve has that positive trend line. Then when we look on the right-hand side at test B for the prepubescent group over 30 minutes, it has a completely inverse effect. We have a negative trend line. I saw that as the pH started decreasing, there was an adsorption capacity decrease as well, which made macromolecules more susceptible to first-pass metabolism. Now, when I started working with my chemistry teacher directly, I noticed many new findings that I didn't see in research before, predominantly that there was an immediate alkalinization of the stomach acid. And this is quite obvious when we think of it, because if you think of a 6-month-year-old, there's no way that the body will be able to tolerate constant pHs of 1 in the stomach, especially when administering a drug. So there was an immediate alkalinization, and the concentration of hydrogen ions decreased as the pH had increased due to the fact that water was a very competitive molecule when binding to these various paracetamol particles in the gastric fluid. Now, strategies to mitigate the negative effects of the gastric pH range with drug bioperformance identified co-administration with acidic beverages, pre-treatment with an organic acid like glutamic acid, and acidic salts of weak bases. All of these application mechanisms I identified through further research. They all showed that employing each of these various strategies, specifically the pre-treatment with an organic acid group, was successful in achlorhydric patients, which are patients that don't secrete any hydrochloric acid throughout the process of drug administration. So all of these three mechanisms are successful in mitigating the negative effects of drug bioperformance. Future research that I wanted to see happening in the space of oral bioavailability specifically was study on achlorhydric patients. As I said, these patients don't make any hydrochloric secretions in their stomach. So it's a lot more difficult for the paracetamol then to have the longer half-life when it makes it into the small intestine for metabolization. I proposed the idea for collaborative multi-species health science, basically using the same rudimentary principles of drug performance in various organisms, as well as anatomy, as I studied in this project in the literature review. We could apply all of these principles to veterinary practice as well, and could evolve potentially into a completely new branch of science, collaborative multi-species health practice. I also looked at activated carbon, specifically to paracetamol. Paracetamol activated carbons are basically carbon molecules that make the paracetamol more porous, as you can see in the diagram below. This expands the surface area and it allows an electron acceptor donor complex to participate in this whole process of administration. There's a huge branch of science that's looking at it right now, and I would love to see how within school systems as well, and in potential future expos, people looking into activated carbons as a potential solution for mitigating poor drug bioperformance as well. Then also indigenous knowledge systems. The following three, carob, myrtle, and quince, were also identified in further studies outside of my research to have a successful effect on drug bioperformance. Now to just conclude, in the tablet form of test A for the post-pubescent group or the adult group, there was a great dissolution at more alkaline levels and absorption decrease in highly acidic ranges of the pH for the gastric stomach. And then in the test sample B for pediatric syrup, there was an increased hydrogen ion concentration in more acidic regions and decreased hydrogen concentration in the more alkaline regions. Reviewing the hypothesis, when we looked at the original, I had predicted that there would be a very high prevalence and presence at the lowest pH. However, this wasn't true completely due to the fact that in test A, I had seen the highest prevalence and breakup decomposition of the drug at the more alkaline regions. Through the research I did, and also the project limitations, which included the inability to use human biochemicals like albumin and lipid-carrying proteins, I wasn't able to observe some hypothesis, but this has nothing to do with the bioavailability concerns that I originally designed to do in my aims. Therefore, I decided to accept my initial hypothesis on the foundation that the graphs that were conducted were in line with the project journal's graph. I would also just like to say thank you once again to all the following people that helped make this project happen, as well as Scifest Africa for giving me this opportunity to share my research. Well, and to the other two speakers that spoke before me as well. Projects were both very, very inspiring. Thank you.
Thank you, Ra'ees. Thank you so much. That was a wonderful presentation. Sorry about that a little bit. That was a wonderful presentation. If there's anyone who has a question for Ra'ees' presentation, you can drop it on the Q&A. I think there it is. Okay, Ra'ees, there's a question that says, do you think your study would have similar outcome on other antigonalins such as aspirin?
That is a great question. Thank you for asking. At the moment, I'm actually further developing my project as well for a future expo, as I just said as well. We are looking at new methods within the project as well, instead of just the mark recapture technique and the pH anti-logarithmic questioning of identifying the amount of negative bioperformance for the drug. So for anticoagulants, we need to first identify how the excipients of the drug. So when we look through the microscope, we don't only see paracetamol molecules, we also see all the other additional things that commercial companies will put into the drug. These all need to be tested across various blood groups for effective systemic circulation in the body. So to answer the question, I'm not entirely sure. I mean, I did follow rudimentary principles because I didn't have the facilities and equipment to further study it as advanced as I would like. But I am doing future research into how that question, how do various anticoagulants play a role in mitigating negative drug bioperformance? Thank you.
Okay. There's another question from Ms. Monica Newton that says, thank you so much, Ra'ees, for a fascinating presentation. As we imagine a possible vaccination for COVID-19 in capsule or in the pill form, do you think that this research could inform this initiative? Did you hear the question, Ra'ees?
Sorry, can you please repeat the question?
It says, thank you so much again, for the fascinating presentation, as we imagine a possible vaccination for COVID-19 in a capsule or in a pill form. Do you think that this research could inform this initiative?
Okay, that is also a great question. Thank you for the compliment. I wanted to say that various drugs and various, when we look at a vaccination in itself, that's a whole new realm because we're looking at specific fragmented parts of pathogens. Each drug, when I speak of drugs, they follow a different role in the body. Some are metabolized in various areas. For paracetamol, for example, it goes through the liver system in order to actually take positive effect. For a drug, for a vaccine like COVID-19, we would need to be studying the immune system rather than looking at the gastric system that I did. So yeah, it depends on how the body is responding to the various inputs that it gets, the medicinal inputs. Is it being absorbed? Is it being targeted? Does it have a target site? So all in all, I think that this type of research that people do help inform the initiative, and they help expand the neurodiversity, if I can put it that way, for future research in drug bioperformance and vaccine bioperformance. But yeah, overall, I also can't give a definitive answer into how a potential COVID-19 vaccine capsule or pill would be successful, but hopefully there is future research into that as well to make it more accessible to more people.
Thank you, Ra'ees. Is there any questions? You can raise a hand if you'd like to ask a question, or you can also drop it on the Q&A box. Seems like there's no one who has a question for now. Ra'ees, thank you so much for an amazing presentation that we had. Hopefully we've learned a lot from the presentation. Thank you so much.
Thank you so much for having me.
Thank you. If there is no one who has a question, I would like to say thank you so much for joining us today at Scifest Africa on another webinar. I would like to say thank you to our presenters for such an amazing presentations, and hoping that we've learned a lot from these presentations, and also inspired our learners to take part in the Eskom Expo for Young Scientists. And we also would like to see you tomorrow on another workshop that we have here at Scifest Africa with Masha Kalika, who will be creating a homemade plant-based paper. And you can follow us on our website, and please register at www.scifest.org.za. And again, thank you so much for joining us and for making time to come and taking your time and being on this webinar for today. Ms. Monica is saying thank you so much to Scifest Africa and the presenters for a very informative session. It really was informative indeed. Thank you so much. We really appreciate this. And as Scifest Africa, we really are thankful, and thank you for joining us for today.